So here is the specification of Byzantine reliable broadcast. So we have the module called Byzantine reliable broadcast, and its instance is going to be referred to as BRB for Byzantine reliable broadcast, of course. And compared to the other reliable broadcast primitives that we have considered, here we instantiate the Byzantine reliable broadcast with the fixed sender S. So another difference, as you are gonna see shortly, is that we will also be concerned with distributing or broadcasting just a single message in a single instance of Byzantine reliable broadcast. And we need that in order to be able to properly specify it. And of course, in practice, we can just chain multiple such instances of Byzantine reliable broadcast to distribute any number of messages that we need. So the interface supported by Byzantine reliable broadcast is as follows. So there is one type of request event, which we are already familiar with, and those are broadcast events of a message M. And the only difference compared to the reliable broadcast for crash failures is that this request can only be executed by a single process S. So the indication events are of the form deliver, and then message source and the message, and it notifies the local instance of a delivery of message from process SRC, which again in our case can only be equal to the sender S. So the properties of Byzantine reliable broadcast appear on the next slide, and those are referred to as BRB1 to BRB5. So the properties satisfied by Byzantine reliable broadcast, or BRB, appear on this slide. So the first property is called validity, and it is very close to the validity property we normally require from reliable broadcast in the presence of crash faulty processes. So it says that if a correct process P broadcasts a message M, then every correct process will eventually deliver this message. This basically means in the Byzantine context is that Byzantine process can't interfere with propagating messages that were sent by correct senders. Okay, so they can't mount some sort of a denial of service attack or something else that would interfere with the message propagation. So the second property, node application, it looks actually quite different from the node application property we are used to deal with, and it says that every correct process delivers at most one message. Okay, and this is at most one because, as we mentioned before, that a single instance of Byzantine reliable broadcast can only be used for propagating or broadcasting a single message. Okay, so this is not a real problem, as we have discussed, because we can always string together multiple instances of Byzantine reliable broadcast to propagate as many messages as we want. So the next property is actually important, in particular in Byzantine context. It's called integrity, and it says that if some correct process delivers a message M with sender P which is correct, then M was actually previously broadcast by P. So in some literature, this property is actually called unforgeability, and it actually means that Byzantine processes can't somehow collude and create a fake message and pretend it to be a message from a correct process. Or in other words, they can't forge a message from a correct process. Okay. So the fourth property is called consistency, and it is as follows. If some correct process delivers a message M and another correct process delivers a message M prime, then both these messages are actually the same. M equals M prime. Okay? And what consistency property actually means is that there is no equivocation. Okay? So we mentioned the problem of equivocation before, and consistency property is what is actually saying that equivocation can't occur. Okay? So even if we have a Byzantine sender and it can try to equivocate, the service that we see, the messages that actually delivered, appear as though the process did not equivocate. Okay, so we can't deliver two different versions of a message that was broadcast. Okay. So the last property is called totality, and it is conceptually similar to the agreement property that we discussed in the context of reliable broadcast algorithms, but it only takes its liveness part. Okay, this is because the actual agreement part is already covered by this consistency property. So totality simply says that if some message is delivered by a correct process, then every correct process will eventually deliver a message. It does not say which message because it's not needed. That's already covered by the consistency property, which says that that message is the same everywhere. So as we discussed before, the totality property is useful in case we want to take some action based on a message being received. Okay, so all correct processes want to execute something in case they receive a message, and for that reason, in order to be coordinated, they need to be sure that all other correct processes will also deliver this message.